Hello everyone. I'm going to show you a proof for the Triangle Midsegment Theorem. So the Midsegment Theorem states that the segment connecting the two midpoints, or the midsegment, of two sides of a triangle is parallel to and half as long as the third side. So just to make sense of the theorem and what we're looking at, let me draw a triangle to start with. Any triangle here, so this is completely arbitrary. So let's say triangle A, B, and C. Now, the midsegment is the segment that connects together two of the midpoints. So because those are midpoints, I know that these segments are all congruent. And let's label this M and N. So this segment here, this is a midsegment. So what we want to show, what we want to prove to justify this theorem so two things. We need to show that it is parallel. So we need to show that MN is parallel to AC, and we also need to show that it is half as long. So also, we need to show that MN is half as big as AC. So those are the two things we need to justify. There are a couple different ways we can approach this proof. One of them is using similar triangles. I know that these two triangles, they share this angle up top here. So you got the little triangle there, the bigger triangle ABC. These triangles, they have a scale factor of 2. Since AB is twice as long as MB, we can see that with the midpoint. So you can justify that with similar triangles pretty easily. But I want to show you a coordinate proof for this theorem. So whenever you're doing a coordinate proof, you want to make sure that you assign coordinates to everything you need to work with. And it's best to try and pick ones that are easy to use. So I'm going to start with some coordinates here. And I need a triangle in my coordinate plane. Now one of the easiest points to use is at the origin. So let's put one of our vertices here. I'm going to call that one A. And I'm going to put one of the sides of my triangle along the x-axis. So then over here we can say this is C. So then to make our triangle, let's just put our other point somewhere up here. So that's point B. So placing our triangle like this, at least we have the point 0, 0 to work with. And then we also have this point here along the x-axis, which has a y value of 0. Okay. Now I need to assign coordinates to each of these. So we know that this one is 0, 0. Point C, it's somewhere along the x-axis. I want this to be completely arbitrary, so we need to use a variable to represent this. And I'm actually going to use the value 2, and let's say, just say 2a. And I know the y value is 0. I'm using 2 times that because I know eventually I'm going to be dividing by 2 because I'm using midpoints. So just to make it easier, I'm planning ahead and using 2. Okay, then point B, this has a different x value than C, so we need to use a different variable. So let's say 2b, and then this has some y value, which we don't know. So again, let's use some variables. So let's say 2c. Okay. The other thing we need is we need our 2 midpoints. So draw those in. And let's say that this is M and this is N. So again, we want to show that MN is parallel to AC, and we want to show that that length is half as big as this. So, first step, we need the coordinates for m and n. I know that they're midpoints, and we have a midpoint formula, so why don't we use that to find it? So to find the midpoint, you add the x's together, divide by 2, and you add the y's together, divide by 2. So we have my two x values, 2b and 0, and the two y values, we have 2c and 0. Okay. The 0 doesn't do anything, so the 2's cancel out, so m is b. Same thing here. So m is the point BC. Alright, now the same thing for n. Okay, the two x values, 2a and 2b. So 2a plus 2b divided by 2. And the two y values, 0 and 2c divided by 2. Okay, so different variables, so we can't combine these together, but they do have a common factor of 2 in there, so we can divide that out from everything. So that's a plus b. And then here, just like we had for point m, the 2's will cancel out, the 0 doesn't do anything, so we get just c. This is a plus b and c. Okay, so now that we got coordinates for m and n, we can start to justify our two properties here. Let's start with the fact that it is parallel. The easiest way to justify that these are parallel is to show that they have the same slope. So let's start by, we're going to do parallel. We're going to do the slope. So let's start with AC. The slope of that segment, I can see here just based on the y values and because I know it's on the x-axis, because of the way I set this up, I know that is a horizontal segment, so it should have a slope of 0, but just to justify that, our slope formula, we subtract the y values up top, and then we subtract the x values in the denominator. So our slope, 0 over 2a, so that's just 0. Okay, now let's find the slope of mn. So again, if I look at these two y values, I see that they are the same. So this should end up being horizontal as well. But subtract the y value is c minus c. And then we have our two x values, a plus b, and then minus b. So our slope is 0. The b's cancel out, 0 over a. So the slope is 0. So because they have the same slope, they are parallel to each other. Okay. The second thing is we need to show their distances here. So we need to show that mn is half as long as AC. So let's do the length. To do this, we can do the distance formula. So again, let's start with AC. So the distance formula, we do our x values, subtract those, squared, and then our two y values, subtracted and squared. That's the square root of that whole thing. So lots of zeros in here, which makes it pretty easy to work with. So here we just end up with 2a squared, and then the square root and the squared, they undo each other, so our length is just 2a, which makes sense because along the x-axis here, that's just a horizontal distance, so it's just how far you need to go to get to c, which is 2a. And now for the length of mn, so our two x values, a plus b minus b, a plus b minus b, and then our two y values subtracted, c minus c, and the square root of all that. So b's cancel out, we just get a squared, c minus c is 0, so that goes away. The square root of a squared, we get mn is a, which is half as big as AC. So, because these two segments have the same slope, mn is parallel to AC, and because AC is twice as big as mn, we know that mn is equal to half of AC. And that was what we were trying to prove. So for any given triangle, the midsegment is half as long, and it is parallel to the corresponding side.